Select the major product of the following reaction. And so we are starting with an alkyl halide and sodium methoxide, which could be either a base or a nucleophile. And so we want to decide what is the reaction pathway that is going to occur here. We know that alkyl halides can undergo both substitution and elimination reactions. And so we want to analyze what we have here. We're going to look at the substrate first and then the identity of the base/nucleophile. So we have a secondary alkyl halide. So a secondary alkyl halide, and secondary alkyl halides tend to undergo either SN2 or E2 reactions. And our base/nucleophile is the methoxide. And this is a fairly small base and a fairly small strong base. You can think of this pretty much the same way we consider hydroxide, OH minus. So this is a strong, small base. And so a strong, small base with a secondary alkyl halide will tend to undergo an E2 reaction. And not only that, because that base is small and not sterically hindered, you will tend to see the most stable alkene that can form as the major product. And so if we are looking at our substrate to determine the most stable alkene, we're used to looking at substitution. We might say, well, we've got a secondary carbon on one side, we've got a secondary carbon on the other side. Does it matter where we form the alkene? Yes. And the reason why that answer is yes is because we have another alkene in here. So we're not just going to be forming an alkene, we're going to be forming a diene. And so if we form an alkene here, that alkene will be conjugated. If we were to form an alkene out here, that you would have an sp3 carbon in between your alkenes, and that would be isolated. So we are going to take the hydrogen that is 180 degrees away from the leaving group from the carbon atom that will give us the conjugated diene. And so that product will look like this. And that is option D.